In this video, I'm going to do a couple of quadratic formula examples using the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Remember, we have to have a quadratic equation that's in standard form, ax squared plus bx plus c equals 0. On question 4, I have x squared minus 2x minus 3 equals 0. I'm checking here. I can see that I'm already in standard form. I already have my equation set equal to 0. So I'm ready to identify my a, b, and c. So a equals 1. Remember, if there's no coefficient written out, we know that that is 1. B is negative 2, and c is negative 3. So x equals the opposite of b. My b value is negative 2, so the opposite of negative 2 is positive 2, plus or minus the square root of b squared. I'm always going to use parentheses around my negative numbers. So negative 2 squared minus 4 times a, which is 1, times c, which is negative 3. And that's all divided by 2 times a, and a is 1. So your first step is always to simplify what's underneath the radical. And if you use your parentheses, you can put this whole line in your calculator to compute. Pause here and calculate the part that's underneath the radical. Hopefully you have, we still have our 2 plus or minus, and hopefully when you put in negative 2 squared minus 4 times 1 times negative 3, you got 16. So we have the square root of 16 there, and 2 times 1 is 2 for our denominator. Now I'm going to look at that 16 along the diagonal of my multiplication chart and see if 16 is a perfect square. And we see that it is a perfect square. The square root of 16 is 4. So we can substitute or replace that square root of 16 with 4. This is nice because we don't have any radicals to deal with. So I'm going to actually split this into 2 parts. That plus or minus means that I have 2 plus 4 divided by 2, and I have 2 minus 4 divided by 2. Let's simplify those. So 2 plus 4 is 6, divided by 2 is 3, and 2 minus 4 is negative 2, divided by 2 gives us negative 1. So we have 2 answers for problem number 4. We have 3 and negative 1. Let's take a look at number 6. And I just copied my quadratic formula for the bottom of my screen so I can have that always in view. So I'm looking and I don't have this equation. I have x squared equals 2x plus 6. So it's quadratic because it has a second, a 2 exponent, but it's not in the form ax squared plus bx plus c equals 0. So I need to make it that way. And to do that, I need to bring everything over to the left side. And I want to bring it to the left side because my x squared is already positive, and I'd like to keep it positive. I like when my leading coefficient is positive. So I'm going to get rid of the 2x by subtracting 2x, but what I do to one side, I need to do to the other. And I'm going to also subtract 6. You can do this all at the same time, or you could do it in separate steps. I have stacked everything over here on the left, but none of these are like terms, so I'm just going to have to rewrite those. So I have x squared minus 2x minus 6 equals 0 because these both canceled over here. When you switch sides, the sign should change. That's always a good check for you to do. So now I'm in standard form, and I'm ready to say what my a, b, and c are. My a value is the coefficient of x squared, which there's no number written out, so we know that that would be 1. My b value is my coefficient of the x term, which is negative 2, now that I have it in standard form. And my C value is my constant. And now that I have it in standard form, my C value is -6. So now we're going to use our quadratic formula. And we have x equals the opposite of b. You can say negative b, but I think it's faster to just think of the opposite. Negative of -2 is +2, but it makes more sense, I think, if we say the opposite of -2, which we know to be +2, plus or minus the square root of b squared. Our b squared is -2, so we'll put that in parentheses, squared, minus 4 times our a value, which is 1, times our c value, which is -6, and that's all divided by 2 times a, and a is 1. So just like we did above, we want to start by calculating the part that's under the radical. So we're not going to actually square root it. We're just going to do the part that's underneath. -2 squared minus 4 times 1 times -6. You can put this whole thing in your calculator as long as you use parentheses. And the biggest reason for that is if I just type in -2 squared, your calculator is going to tell you that that's -4. But we know that -2 squared is -2 times -2, which is +4. So that's where it can get tricky using a calculator. Pause for a moment to make that calculation. Hopefully you found that the part under the radical was equal to 28. So we have 2 plus or minus the square root of 28, all divided by 2. And so we want to take a look at square root of 28, or 28. Is 28 on our diagonal? Is it a perfect square? So I need to factor 28. And so I know 2 times 14 is 28. 2 is prime, 14 is not. It's still even. So I'm going to divide 14 by 2, and I'm left with 7. 7 is prime, so I have 2 times 7 is 28. And I can see that I have a pair. And remember, I put the pair under any pairs that I have under one radical, and everything else multiplied under the other radical, which was just 7. The square root of 2 times 2 is the square root of 4, which is a perfect square. The square root of 4 is just 2. So the square root of 28 is the same value as 2 times the square root of 7. So I'm going to replace that in my equation as I'm simplifying. So I have 2 plus or minus, and instead of writing the square root of 28, I'm going to write 2 square root 7 because that's its simplified form, all divided by 2. I also like to break this fraction apart so that that denominator is under both parts of my numerator. So 2 over 2 plus or minus, and then my 2 root 7 all over 2. Because 2 divided by 2 is 1. And I have 2 over 2 in this part over here. And it would be 1 times root 7, which is just the same thing as root 7. So my answer for this would be 1. Oops, I forgot my plus and minus. I just hit a plus. 1 plus or minus square root 7 would be the simplified form for that. I can't combine it any further because the radical, the square root, is not a like term. It's not like with the integer value that I have right here.